in probability, to solving the question, there are so many theorems given by the statistician, like addition theorem, multiplication theorem, Bernoulli theorem. Similarly, one more theorem we are going to discuss in today's video, that is called Bayes' theorem. This theorem is applicable when we are having some new additional information related to our question to the probability. Then we will use the Bayes theorem, and this theorem is called inverse probability theorem also. Sometimes we are giving conditional probability also with the probability. So this is the additional information related to the probability, and in such kind of the conditions we have to use the Bayes theorem of the probability. So in today's video we will learn how we can use the Bayes theorem to solve the problem of probability. We will having two questions related to the Bayes theorem in today's video. The very first question I am taking, the question is this: the probability of appointment of one of the three persons, a politician, a retired IAS officer and a educationalist, as a vice chancellor of a university is 35%, 25% and 40%. The three persons that may be the vice chancellor of the university, the probability, first one is politician, retired IAS and educationalist. The percentage chance is 35%, 25% and 40%. And the appointed will, the probability of the standard of research activity will be encouraged by and promoted by them is 0.4, 0.8, 0.9. Then what is the probability that research be promoted by the vice chancellor? The question of this, there in a university, the percentage chance to be appointed, there may be three persons, one is politician, second one is a retired IAS, third one is an educationalist. The percentage chance to be vice chancellor is a politician is 35%, to be a retired IAS is 25% and to be educationalist is 40%. Now conditional probability also given, that if the politician will appoint, he will promote the research, the probability is 0.4. If a retired IAS is to be appointed as a vice chancellor and he will promote the research, the probability is 0.8. And if a educationalist will appoint, he will promote the research, the probability is 0.9. So we are to calculate the probability that the research will be promoted in the university. So the very first we are having Bayes theorem. So we are having the Bayes theorem. So the very first we are having event A1, A2, A3. Okay, so first event is over there. Pre-probability, this is 0.35, this is 0.25 and this is 0.40. Now conditional probability is also given. That is B divided by A1, that is 0.4, 0.8, 0.9. This information is given. So the joint probability we have to calculate. That is B intersection A1, joint probability B. So the very first one, the joint probability, if a politician will appoint and he will promote the research, so that is PA1 is 0.35 and he will promote the research BA1, that is 0.4. First condition we are having that the possibility of appointment of a politician is 0.35 and he will promote, this is the conditional probability, if he will appoint he may promote, so that is 0.4. so P A intersection B, that is PA1 multiplied by PB divided by A1, so that will be 0.35 multiply 0.4, 0.35 multiply 0.4, 0.35, 0.35 multiply 0.4, so that is 0.14. Similarly, possibility of appointment of a retired IAS is 0.25 and he will promote the research, that possibility is 0.8. So PA2 intersection B, that is PA2 multiplied by probability of B when A2 is appointed, so 0.8. So there will be 0.25 multiplied by 0.8. So 0.25 multiplied by 0.8, that is 0.2. Similarly, third condition, the chances of appointment of a educationalist is 40%. It means PA3 is 0.4 and probability of research, that is 0.9. So 9 4 ja 36, 0.36. Okay. So this is the probability of A1 intersection B, that is probability of A multiply probability of B when A is happened, probability of A2 intersection B, that is probability of A2 and probability of B when A2 is happened, and probability of A intersection A3 intersection B, that is probability of A3 multiply the probability of B divided by A3. So the joint probability will be 0.14 plus 0.20 plus 0.36. So this value will be 0.7. So we can calculate, with the help of this, we can calculate the joint probability. The very first, you should know, the question is saying that the percentage chance of the total probability, that is probability of A1 intersection B plus probability of A2 intersection B plus probability of A3 intersection B. That is probability of A1 intersection B, A2 intersection B, this is the probability of B. So that is probability of A1 multiply probability of B when A1 is happened, plus probability of A2 multiply by probability of B when A2 is happened, and plus probability of A3 and probability of B multiply A3. So this will be probability of 0.35 multiplied by 0.4 plus 0.25 multiplied by 0.8 plus 0.4 multiplied 0.9. So this will be 0.14 plus 0.20 plus 0.36. So the probability will be 0.7. So with the help of the Bayes theorem, we can calculate the probability. It's a reverse probability. because here the conditional probability is given, already given, the simple probability and the conditional probability is given. So for getting the possibility of overall research research will be given priority or promoted by the vice chancellor, there is a chance of 70% chance is over there that the research will be promoted by the vice chancellor. So in this Bayes theorem, we have to go as the question is saying. The question is saying, the first question is given the pre-probability that there is a 35% chance that there will be a politician, there is a 25% chance that will be a retired IAS, and there will be a 40% chance there will be educationalist. So this is a pre-probability we can saving the A1, A2 and A3. Now condition is there, if politician will appoint, he will promote the research. So this is a conditional probability. So the probability of B when A1 will appoint, that is 0.4. The probability of A2 when probability of B when A2 will appoint, that is 0.8, and this. So for getting the overall probability we are having, this is probability of A intersection B plus probability of A2 intersection B plus probability of A3 intersection B. With the help of this we can calculate the overall probability, how the research can be promoted in the university. So this is called the Bayes theorem. We are having one more question related to the Bayes theorem. So it will make you perfect in how to use the Bayes theorem in solving the probability problem. One more question. 3 urns contains marbles of different colors and A contains 4 white. There are 3 urns. The first one is this, second one is this, and third one is this. First 3 urns contains marble of different color. First contains 4 white, 5 black and 3 red marble, and second contains 1 white, 2 black, 3 red marble, and 3 contains 2 white, 1 black, 1 red marble. Repeating the question. 3 urns contains marble of different colors, and first contains 4 white, 5 black and 5 red marbles, and second have 1 white, 2 black and 3 red marble, and third has 2 white, 1 black and 1 red marble. 1 urn is selected at a random and 2 marble are drawn that happen to be white, 1 white and 1 red. What is the probability that they come with urn first and second and third? 1 urn is selected at a random and 2 marble is drawn. There should be 1 white and 1 red. 1 white and 1 red. So this is also a case of conditional probability. The very first we have to select urn. So the probability of selecting urn A1, A2, A3. A1, A2, A3. So the pre-probability of selecting, that is 1 by 3, 1 by 3, 1 by 3, because among 3, 1 urn to be select. So the probability of 1 by 3 of selecting first urn, selecting second urn is also 1 by 3, and selecting of third one is also 1 by 3. For getting 1 white or 1 red, so this is the pre-probability, that is 1 by 3 and 1 by 3. Now conditional probability for that. One white, that is 4C1. 1 red, that is 3C1. divided by 12C2. From this, one white, that is 1C1, one red, that is 3C1, divided by 6C2. From this, one white, 2C1, one red, 1C1, divided by 4C2. So this is the conditional probability. Here total number of events is 12. So selecting 2, that is 12C2. One is white, so 4C1. Second one is red, that is 3C1. In total number of events is 6, so 6C2. One white, that is 1C1, and one red, that is 3C1. Here the total number is 4, so 4C2. One white, that is 2C1, one red is 1C1. Now solving this, 4C1 multiply 3C1 upon 12C2. So 4 upon 1, 3 upon 1 upon 12 multiply 11 upon 1 multiply 2, that is 6. 3 2 ja 6, 2 2 ja 4. So that is 2 upon 11. So that is first one is 2 upon 11. We have to solve this type. 12 upon 66 is over there. We can having this also, no problem at all. We can having in the form of this 12 upon 66 we can write, that is 4 divided 1, 3 divided 1 upon 12 divided 11 divided 1 divided 2, that is 6. So we are having 12 upon 66. No problem. We can write in this manner also. Second, 1C1 is 1 multiply 3 divided 6 multiply 5 upon 1 multiply 2. So that is 3. So 3 upon 15. Okay. Third one is given 2 upon 1 multiply 1 divided 4 multiply 3 upon 1 multiply 2. So that is 2 upon 6. So that is conditional probability of this. And conditional probability 12 upon 66, 3 upon 5, 2 upon 6. Now joint probability. Probability of B upon A. So 1 by 3 multiply 12 upon 66. So that is 4 upon 66. What we have done? 1 by 3 multiply 12 upon 66. 3, 4. 4 upon 66. Or we can having 2 upon 33. So we can write here 2 upon 33. Second one, 1 by 3 multiply 3 by 15. Firstly, you should understand this. Probability of A1 intersection B, that is probability of A1 multiply probability of B when A1 is happened. So that is 1 by 3, that is A1 multiply 12 upon 66, that is 4 times, 2 times 3, 3. Second, probability of A2 intersection B, that is probability of A2 multiply the probability of B when A2 is happened. So that will be 1 by 3 multiply 3 by 15, that is 1 by 15. And probability of A3 intersection B, that is probability of A3 multiply by probability B upon A3. So that is 1 by 3 multiply by 2 by 6. So that is 1 by 9. Okay. So the addition of joint probability. Now we will calculate the addition of joint probability, that is 2 by 33 plus 1 by 15 plus 1 by 9. So we will have to take the LCM of this, that is 495. 33 multiply 15 multiply 9. Okay. 33 multiply 15, 495. So 15 2 ja 30 and 33, 55. So the addition will be 55 plus 30 plus 33, 118 upon 495, 118 upon 495. So this will be the addition, 118 upon 495. Now the probability. Okay. Now probability that ball are from first end. Now we are to calculate the probability, that is joint probability. Now period probability. We are having reverse probability, inverse probability. That is B divided by, this is the probability of B. So for calculating inverse probability, we are having probability of B, probability of A intersection B divided by probability of B. So that is probability of A intersection B divided by probability of B, or we can say that this is 1, this is 2, this is 3 and this is 4. So we can saying that will be 3 upon 4. 3 divided by 4. Because probability of B, how we calculate? Probability of B is probability of A1 intersection B plus probability of A2 intersection B and probability of A3 intersection B. So this is probability of A1 multiply by probability of B when A1 is happened plus probability of A2 multiply by probability of B when A2 is happened plus probability of A3 multiply by probability of B when A3 is happened. So we have calculated this joint probability. Now this is 2 by 33 plus 1 by 15 plus 1 by 9. So addition is 118 upon 495. We have already calculated. Now for probability of each, we are to calculate. So the very first 2 by 33 divided by 495 upon 118. 2 by 33 divided by 499 118, 30 upon 118. So that is 30 upon 118. 495 multiply by 2. 495 multiply by 2 divided by 33, that is 30. Second one is 1 by 15 divided by this, so having 495 upon 118. So 495 divided by 15, that is 33 divided by 118. And last one, 1 upon 9 multiply 495 upon 118. So 495 divided by 9, so that is 55 upon 118. So the probability is 30 ratio 33 ratio 55. So addition of this all is 118. So that is addition of all three is 118. So the probability that will be from first turn, this is 30 upon 118. The ball, one white and one red ball, one marble may be from second turn. The probability is 33.88 118, and the probability that this will be from third turn, so there will be 55 upon 118. In this manner we can use Bayes theorem to calculate probability. This is the methods of calculating reverse probability. It's very simple. In case we have given the conditional probability already, then we have to use Bayes theorem of the probability. Generally in examinations there is a little chance that a examiner will ask about the Bayes theorem. I have never seen a question related to the Bayes theorem in examination, but for in your syllabus it is included, so I have made this video. So I think it's not so important, but you must know how to calculate Bayes theorem. That's why I have prepared this video. So I think with the help of this video you may be learn how to use Bayes theorem. Thank you once again.